it is clear that this straight line makes angle of 45 degree with the x-axis as well as y-axis. Polynomial of this form, and by making this table we can draw the graph. Let us recall the matter: absolute value or modulus. Modulus of a number is called its unsigned magnitude. Now I am going to discuss few standard real function already discussed in the earlier episode. If the domain and range for a given functions are subsets of set of reals, then we call those functions as real valued functions, simply real functions. Now there are standard real functions. I am going to discuss them one by one. Also the graphs of those real valued functions. Number one, identity function. Here function is x to set of reals. X is also subset of set of reals given by fx equal to x. The function is defined by fx equal to x. Now from this we can easily find we take fx as y. If we consider negative values, minus 1, minus 1, minus 2, minus 2, minus 3, minus 3, that means value of x will be same as the value of fx. Now we can draw the graph. If we call this point 1, 1, then this will be set to 2. This point will be minus 1, minus 1. Say this point will be minus 2, minus 2. Therefore, this straight line which passes through the origin, also the points 1, 1, 2, 2, 0, 0, minus 1, minus 1, minus 2, minus 2, minus 3, minus 3, etc. It is clear that this straight line makes angle of 45 degree with the x-axis as well as y-axis. Therefore, this is the graphical representation of fx equal to x. Now we move number 2. Constant function. from the name it is clear that for any real value of the variable x, value of fx will be constant. This function is defined now. If we represent that with the help of graph, and if we make the table, then the table will look like this. For different values of x, value of will be same, y, where y is equal to fx. Now if we take k positive, then y equal to k, fx equal to k will be the straight line which is parallel to x axis, and different points will lie minus 3k, minus 2k, 0k, etc. will lie on this straight line. This is the graph of the constant function y equal to fx equal to k. Then we have polynomial function. This is given by a naught x to the power n, a1 x to the power n minus 1 plus a2 x to the power n minus 2 plus dot 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 plus an, where n integer, of course positive, also 0, and a naught, a1, a2, an are constants. This is the general form of the polynomial function. We can take example, fx is equal to x square. Fx equal to x square, let y equal to fx is equal to x square. Now if we draw the graph of this function, actually we need more points. In earlier class or lower classes, we had drawn graphs by taking 2 or 3, at least 2 or 3 values of x, and we found values of y. Then we plot those values on the graph sheet, taking 2 mutually perpendicular lines. Horizontal one is called x-axis and vertical one is called y-axis. We plot this point with respect to a scale. Then we join those points to get the graph. Here we need at least 9 points. We take here few and show the nature of the graph. Here 0, it will be 0, plus minus 1, it will be 1, plus minus 2, it will be 4, plus minus 3, it will be 9, plus minus 4, it will be 16, plus minus 5, it will be 25. If we take more points and plot those, then we will get I think already you have learned that this curve is a parabola. Making this table, we plot 0 0, then 1 1, then minus 1 1, then 2 4, then minus 2 4, then 3 9, minus 3 9, 4 16, minus 4 16, 5 25, minus 5 25, etc. And we join those points by a freehand curve and we obtain this parabola. Also, we can take any polynomial of this form, and by making this table we can draw the graph. Then we have rational function. Rational function will be of the form fx is equal to gx by hx. That means fraction form. Here, for existence of fx, hx must not be 0. This is to be kept in mind, and x is any real number except the values of x for which hx vanishes. Now we can take a simple example. Fx is equal to 1 by x, taking y is equal to fx, y will be equal to 1 by x, and if we form table and draw the graph, the graph will be Actually, to draw the graph of y equal to 1 by x, if we take the points, the table, also we can take the negative values of x and plot those values. We get two branches. This is one branch, this is one branch. Actually, this type of curve is called hyperbola. Next we move to modulus function. Modulus function. This is fourth one, modulus or absolute value. Function. This is given by fx is equal to, already you have learned this symbol, mod of x. Now, definition for fx will be minus x if x is negative, 0 if x is equal to 0, and x if x greater than 0. Let us recall the matter, absolute value or modulus. Modulus of a number is called its unsigned magnitude. Unsigned magnitude. That means modulus of say minus 5 is 5. Modulus of plus 6 is equal to 6, etc. Now, plotting different points and joining them, we will get the graph. When x is negative, x, y, I take like this, minus 0.1, then it will be 0.1 minus 1, 1 minus 2, 2, etc. When x is positive or equal to 0, then I have taken here y is equal to fx. Then for 0 it is 0, 1, 1, 2, 2, 3, 3, etc. Now if we plot and this is origin, the graph will consist the graph consists of OA ray, O is the origin, and OB ray. The graph will consist two rays OA and OB. Here O is the origin.